This video will show you how to calculate and plot both the clean price and the invoice price of a particular bond. In this example, it will be a bond issued by Ford Motor Company. And we can look at the details here. The bond has a coupon rate of 8.9% and matures on January 15th, 2032. So let's take this information and put it into a spreadsheet. 8.9%. Coupon rate, maturity date 1/15/2032. Redemption percent of par will be 100%. This means on the maturity date, the bondholder will get 100% of par value returned to them. So the entire face value of par value, which typically is $1,000. And what else can we glean from this page? We see, for example, when the bond was issued, this is in thousands. It was worth $502,000, $502 million in fact, and currently outstanding is $151 million, which shows us that Ford has repurchased some of this bond in the open market in the meantime. We also know the payment frequency is semi-annual, meaning the bond makes its coupon payments in 2 installments separated by 6 months, so twice a year. You get half the annual interest that is due to you. Frequency is 2 payments per year. The basis is assuming every month has 30 days and there are 360 days in the year, which in our Excel function will correspond to the value 0. First thing we do is calculate the coupon that will be paid every 6 months in percent of par value. So the par value is assumed to be 100 times the coupon rate divided by the frequency gives us a coupon of 4.45% of par value every 6 months. If this bond has a face value of $1,000, then the 6 monthly coupon is $44.50. Okay, now we want to figure out what is the clean price of the bond between August 10th of this year and the maturity date of this bond. So this is probably the most tedious part of the entire exercise here, filling this column with the dates until January 15th, 33. So I'm pulling this down. This will take a while. January 15th, 32 will be around here. There we go. Now I jump to the top and I'm going to freeze my panes. So now when I jump to the bottom, I still have my column headings here. Okay, let's figure out the clean price of the bond using Excel's price function. It asks for the settlement date. That's what this column is for. The maturity date, to make that absolute. So the value stays the same, and I copy this formula down. The coupon rate, again making it absolute. The yield to maturity, which in this example is assumed to be 6%, constant at 6%, making it absolute. Redemption in percent of par value, 100, making it absolute. Frequency is 2, making it absolute, comma, the basis is 0, making it absolute. Give me a price of 126% of par value. Copy this all the way down. And now, let me highlight these 2 columns. This will be 100 because the bond price converges to par value. So the bondholder will get the par value on the maturity date of the bond. Okay, highlighting the entire column, trying to plot this. by inserting a line chart. And we can see, we move this to a separate sheet. We can see that the bond price converges to par value over time until it reaches par value on the maturity date of the bond. It starts out as a premium bond, meaning the price is above par value, greater than 100%, and is reduced, gets smaller and smaller day by day until it reaches par value. This is so because we assume that the yield to maturity, the market interest rates, are constant at 6%. If market interests change over time, as they do, then there would be some fluctuation around this line, but it would still converge to par value. Now to the second part, we have to figure out the accrued interest so we can calculate the invoice price over time. So firstly, we need the days in each coupon period, and there's a function in Excel. It's called coupon days. It asks for the settlement date, the maturity date, making this absolute, the frequency, making this absolute, and the basis, making this absolute. It shows how many days are in each coupon period. And unsurprisingly, that's 180, because a bond assumes that every month has 30 days and there are 360 days in the year. More interestingly, we want to figure out how many days have passed since the last coupon was paid. And again, Excel gives us a function for that. It's called coupdayBS. BS actually stands for beginning to settlement date in this case. So we need the settlement date, the maturity date, the frequency, and the basis, making those all absolute. It shows, for example, that on August 10th, 25 days have passed since the last coupon payment. We know the maturity date is January 15th, meaning coupons will be paid on every January 15th of every year, and adding 6 months to that, July 15th of every year. So since July 15th to August 10th, that is 25 days. That's how this value is calculated. Now we can calculate the accrued interest, how much interest has accrued since the last coupon. And for that, we just divide the days since the last coupon by the days in the entire coupon period times the coupon that is paid, making only the coupon itself absolute. So it's a small amount. But again, this is in percent of par value. Copying it all down. The invoice price is just the sum of the clean price plus accrued interest. To plot the invoice price in our chart, we go to the chart, right-click on it, click Select Data, and add another series to it. The name of the series is just the invoice price, or you can type that in, and the values are these numbers here, from F12 to F4918. We also have to add labels for the horizontal axis, which we find here, highlighting the entire column, clicking return, and then OK. It's nearly good. Let me make one correction. Let me just make this 100. So we see a sawtooth pattern. While the flat price goes down smoothly, that's why it's called the flat price, the invoice price actually goes up until the date of a coupon payment, then drops by the amount of the coupon, which is 4.45% of par value, or $44.50, and then it accumulates, it accrues over the period, over the length of the coupon period. And that is our plot of both the flat price and the invoice price.